Hello, welcome back, class. Today we're going to be talking about function notation. Now, you already should have completed the booklet and the practice for defining a function, so we should all know what functions are. Now we want to learn about how do we read and write functions. So, function notation is used with something called f of x. Now, f of x is always going to be equal to something. Down here we can see that x is the input and f of x is the output. So we're putting x into the function and we're getting our f of x output. Now, f of x is usually a y. So if we look at this example, for every hour you work, you get paid $8. So x is the input, the number of hours you worked. That's the independent variable. And the dependent variable, or the dependent variable or the output, is going to be how much you get paid, which is going to be 8x. So let's suppose you work 5 hours. If you work for 5 hours, x is going to equal 5. So we're going to input f of 5, which is going to equal 8 times 5. And as we know, 8 times 5 equals 40. So our output, f of x, is going to equal 40 when x is equal to 5. So when you work 5 hours, you get paid $40. So if you want to scroll down a little bit, it says, what if you were paid $56? Then how many hours did you work? So this time we know right off the bat that f of x equals 56. So they give us the output and they want to know what the input is. So we have 56 equal to 8x. Now 8 times what equals 56? We can divide by 8 and we get x equals 7. So when you work 7 hours, you get paid $56. So using this function notation, we can get an output when given an input, or we can get an input when given an output. So let's think of another example. You are ordering shirts online. Each shirt is $10 and there is a shipping fee for $5 for every order. So the input is going to be how many shirts you buy, and then the output is going to be the cost. So how much you spend is going to depend on how many shirts you buy. So our f of x is going to equal, so each shirt is $10. So the number of shirts is x, so we're spending $10 for each shirt plus an automatic $5 shipping fee. So our f of x for this equation would be 10x plus 5. $10 for each shirt, $5 for the shipping fee one time. Now it asks below, how much would you spend if you bought 4 shirts? So 4 is going to be the input that we're going to put in for x. So we have f of 4 is going to equal 10 times 4 plus 5, which equals 40 plus 5, which equals 45. Ooh, that is a bad 4. Anyway, you're going to be spending $45 if you buy 4 shirts. So 4, the independent variable, the input, we're putting it in, and we're spending $45. So flip to the next page. We have function notation continued. So function notation is useful because you can just plug in any value you want for x. So let's look at 2 functions. We have f of x equals x squared plus 3, and we have g of x, which equals x minus 2. So we can plug any value into x that we want into our equations f of x or g of x. So what is f of 2? Well, anywhere we see an x, we're going to put a 2. So f of 2 is going to equal 2 squared plus 3. We begin solving that. 2 squared equals 4 plus 3 equals 7. So f of 2 is going to equal 7. So when we input a value of 2, our output is going to be 7. Now, function notation is also useful because you can begin doing operations with other functions. So we have what is f of 3 plus g of 2. So we have our f of x up here, so we're going to plug in a 3 anywhere we see an x. So we're going to have 3 squared plus 3. Now we're going to add g of 2. So now we're going to be looking at g, and anywhere we see an x, we're going to add a 2. So we have plus 2 minus 2. Now when we solve this, 3 squared is going to be 9. 9 plus 3 is 12. And then we know that 2 minus 2 equals 0. So f of 3 plus g of 2 is going to equal 12. Now, inputs don't have to be numbers. You can input anything that you want. So let's say we wanted to know what f of x plus 1 is. We still do the same thing. Anywhere we see an x, we're just going to replace that with x plus 1. So we have our equation. Now, instead of having just a number squared, we're going to have x plus 1 squared plus 3. So we need to square x plus 1 and then add 3. So if we actually factor that out, we're going to have x squared plus 2x plus 1 plus 3. Now that x squared plus 2x plus 4 is going to be your output. So if we input x plus 1, we're plugging in x plus 1 for our x, we're squaring it, we're adding 3, and we're going to get x squared plus 2x plus 4. Now scrolling down a little bit, we don't even need an actual function to use function notation. Sometimes we can do it with just a table. So we have f of x here on the left, we have g of x here on the right. So if we want to know what is f of 3, we just look for the input value of 3 and go over to the output. It tells us when 3 is inputted, 12 is outputted. So without even doing any math, we know that f of 3 is going to equal 12. Now we can do the same thing for g of x. We come down to x equals 4. We look over in the table. We see that when 4 is inputted, we get an output of 16. Now it also makes it a little bit easier. Hold on, that was bad. It also makes it a little bit easier to add two different functions using tables. We have what is f of 2 plus g of 3. Well, if we look at our table, we know that f of 2 equals 9, and we know that f of g of 3 also equals 9. So f of 2 plus g of 3 is going to equal 9 plus 9, which is going to equal 18. So function notation, you have an input, you have an output, x is the input, and then f of x or g of x or h of x or any number you want of x is going to be your output. Thank you and have a good day.